In this example, we'll be using the linear and angular speed formulas. Suppose that point P is on a circle with radius 10 centimeters, and ray OP is rotating with angular speed pi divided by 18 radian per second. Find the angle generated by P in 6 seconds. So let's begin by writing down the angular speed, which we use the Greek letter omega. The angular speed is equal to pi divided by 18 radians per second. Now, the formula for omega is that omega equals theta divided by t, the angle divided by the time. Now, the time we've been given is 6 seconds. So we can substitute pi over 18 for omega. We can substitute 6 for t, leaving us the variable theta. And now, of course, what we want to do is multiply both sides by 6. So 6 times pi divided by 18 is equal to theta. And when we simplify this, we'll write theta first. Theta would be pi divided by 3 radians. So that's the angle generated by P in 6 seconds. Let's look at another part where we want to this time find the distance traveled by P along the circle in 6 seconds. So for this example, we want to write down that we just found that P generates an angle of pi over 3 radians in 6 seconds. So in this case, we have the angle that's been generated, and so we use the formula that S, which is the arc length, equals r theta. R, if you remember, is 10 centimeters, so this would be equal to 10 times the pi divided by 3, and that will give us an answer in centimeters. So therefore, S, the distance traveled by that point P in 6 seconds, would be 10 pi divided by 3 centimeters. Let's work one more part. Let's find the linear speed of the point P in centimeters per second. Now, to do this, remember that we just found S, the distance it traveled, was 10 pi divided by 3 centimeters in 6 seconds. What we're interested in is the linear speed, which is equal to S, the distance it traveled, in the amount of time that it traveled. So this would be equal to 10 pi divided by 3, that's our S value, all of that divided by 6. So this would be equal to 10 pi over 3 divided by 6. When we divide by 6, we can rewrite this as 10 pi over 3 times, change the operation to multiplication, and take the reciprocal of the number 6. Then, simplifying this, we would find that V, the linear speed, is equal to 5 pi divided by 9 centimeters per second. In this example, we'll be finding the angular speed of a pulley and the linear speed of a belt. A belt runs a pulley of radius 6 centimeters at 80 revolutions per minute. Find the angular speed of the pulley in radians per second. So what we know is there are 80 revolutions per minute. And we know that 1 revolution is equal to 2 pi radians. So we can use this information. We multiply the number of revolutions times the fact that each revolution is 2 pi radians, 80 times 2 pi, to find the product is 160 pi, and that would be radians per minute. Next, what we'll remember is, of course, we want this in seconds. We know that 60 seconds is equal to 1 minute. So therefore, we want to take this number and divide it by 60. So this would be our angular speed is equal to 160 pi divided by 60. And let's simplify that to 8 pi divided by 3, and that would be radians per second. Well, now let's take a look at the next part, which is to find the linear speed of the belt in centimeters per second. So in this case, the linear speed, v, is equal to r times omega. And this would be r, remember, was 6 centimeters, times the omega we just calculated, 8 pi divided by 3. This would equal 16 pi. And if we wanted to approximate that, it would be approximately 50, and that is in centimeters per second, which is what we were asked to find. That's the linear speed, 50 centimeters per second. In this example, we'll be finding the linear speed and the distance traveled by a satellite. A satellite traveling in a circular orbit 1,600 kilometers above the surface of the Earth takes 2 hours to make an orbit. The radius of the Earth is approximately 6,400 kilometers. And you can see in the diagram the radius of the Earth, 6,400. The fact that the satellite is another 1,600 above the surface of the Earth, and that's the orbit through which it rotates. So now what we want to do is approximate the linear speed of the satellite in kilometers per hour. The first thing we want to do is recognize and calculate what the radius is. The radius is that of the Earth, 6,400 kilometers, plus the distance that the satellite is above the Earth, 1,600 kilometers, giving us a total of 8,000 kilometers. Now, one orbit is the equivalent of saying theta equals 2 pi in terms of radians. So now we can use the formula S equals r times theta, where r is the 8,000 kilometers, and theta is the 2 pi, which we multiply those together, giving us a result of 16,000 pi. And that would be kilometers. Next, what we remember is that it takes 2 hours, let's write that down, 2 hours for one orbit of the satellite around Earth. So therefore, V is equal to S divided by T, that's our formula, and we know that S we just calculated, 16,000 pi divided by t, the time it takes, 2 hours. And so this would be equal to 8,000 pi, which we can then approximate 25,000, and it's kilometers per hour. Let's continue and find the approximate distance the satellite travels in 4.5 hours. Well, this time, what we're going to do is use the formula that s, the distance it travels, is equal to its speed times the time it travels, so s equals v times t. We just calculated in the first part that v is 8,000 pi. We're going to multiply that times the number of hours, 4.5. This would give us 36,000 pi, which we can then approximate as 110,000 kilometers.